Okay, so it seems like there's still a lot of confusion on axial deformation, so we're going to do a quick review of quiz 8. So we have this steel rod, 20 millimeter diameter, with the axial forces shown, the 50, 50, and the 40. They want you to determine the displacement of NC, starting from the right end of the rod. So basically what that's asking for is what is the total displacement of C with respect to A. So displacement AC. And they give you Young's modulus. So what do we know? We're given the diameter, which the first thing I always do is find the radius, then get that into meters, because that's like our standard units. Take the gigapascals, convert that into pascals, because it's important to know that giga is times 10 to the ninth. Then find the area. Pi r squared. Some of you messed up and used the diameter in here, so that gave you a wrong area. And finally, we know our equations. We know that the axial displacement equals PL over AE. So we know A, we just found the area. We know E because we're given E, and L is just the length of each segment. It is not the length of the entire rod. So the only thing that we're in charge of finding is P, the normal force. You also know that the total displacement is equal to the sum of the displacements of each section. So displacement from A to C is equal to displacement AB plus displacement BC. So all you have to do is find the two displacements and sum them together. So like I said, the only thing we need to find is P. And then all we can do is plug and chug. So finding P for segment AB. So I'm going to focus on this segment, and I start off by cutting the beam or the rod in between this segment. So I cut it between points A and B. So from there, what happens? So if I cut it, I can either choose to look at everything to the left or to the right. I have known forces to the left, so I'm going to cut it, this is right. Pardon my left and right issues. So I'm going to look at everything to the right, and I do the sum of the forces in the x direction. So I have negative n, because it's going in the negative x direction, minus 50 plus 40 equals 0. And I end up with n equals negative 60 kilonewtons. Okay, it's negative, which means that the way that I drew it initially is incorrect. It should actually be pointing inward. So overall, my normal force is going to be 60 kilonewtons inward, or facing to the right. And then if you look, you have an equivalent 60 kilonewtons pressing inward towards the rod on this side by taking 100 minus the 40. So basically what this means is you have a compressive force here that's going to end up compressing the rod. So it's important to keep this negative 60 kilonewtons. So N for segment AB is negative 60 kilonewtons because it is compressive. So compressive is negative, tensile is positive. Okay, then we're going to move on to segment BC. So we're going to find P by doing the exact same thing. We're going to cut the segment, cut in between segment BC, and then look at either everything to the left or to the right. And I chose to look to the right because there is only one force here. So I cut it, I look at everything to the right, sum of the force in the x direction, so negative n because it's pointing in the negative x direction, plus 40 equals 0. So I end up with n equals 40 kilonewtons. That means that the way that I drew my force, this n, is correct. So it should be pointing outward from the rod. And so they're both pointing outward. That means that my rod is in tension here. So remember, tension is positive. Tension means the rod is being pulled apart. Okay, so now we have our n for segment BC. So the last thing we need to do is kind of figure out what we have for each segment. So we know that displacement equals PL over AE, total displacement equals segment AB plus segment BC. So for AB, we found negative 60 kilonewtons. The length of AB is just 600 millimeters. Some of you were putting in 1 meter or 1 millimeter. I don't know why, I was really confused. The segment length is 600 millimeters. The area is what we calculated. E is the same. For BC, we found 40 kilonewtons. The length is 400 millimeters, right? And A is the same as for AB, and so is E. So now all we have to do is plug and chug. So I started with just symbolic equations. So delta AB plus delta BC. So PAB LAB over AE plus PBC LBC over AE. And I pulled out the AE because it's common for both of them. So I end up with kind of this reduced equation. So now all I have to do is plug in my knowns. So I calculated the area, I'm given E, and all I have to do is plug in all the P's and the L's. So in this portion, keep in mind you need to keep the sign that you got originally. So negative 60 times 10 to the third newtons times the length, which is 0.6 meters, plus 40 times 10 to the third newtons times 0.4 meters. And always make sure that you're working in newtons and meters and pascals. You don't want to have gigapascals in there. You don't want to have kilonewtons in there. All standard units, so that in the end you end up with a length. So displacement here is negative 0.318 millimeters once you do all the calculating. So it's negative, and what does that mean? It means that this end C is going to end up displacing to the left. So this rod is going to overall get a little bit shorter, just slightly, by 0.318 millimeters. So yeah, I hope that clarifies things just a little bit.